Hello everyone, this is week 7 of our Intelligent Agents in Learning Environments course. We're going to be talking about what AI agents are and how they are made. Today, we're going to go over what a YAML file is, what an AI agent is, and how to create a multi-agent AI system. First, we're going to talk about what a YAML file is. YAML stands for yet another markup language, and it is a human-readable data serialization language. It is commonly used for configuring files and data exchanging. It has two main characteristics that make it different from other languages: its structures and data typing. YAML has a hierarchical data structure through whitespace indentation. This means that spaces and indentations are used to visually organize and structure the code to make it easier for human readability, and allows us to easily indicate nesting. While the number of indentations used does not matter, elements within the same category must have the same amount of indentations, while elements of different categories must have a different amount of indentations. YAML's data typing is different from other languages because of its automatic type detection and extensibility. In simpler words, YAML can automatically detect what the data type of an element is. For example, common data types such as strings, integers, and booleans do not need to be explicitly declared. Its extensibility also differs from other languages, such as JSON languages, because it allows the declaration of custom data types, which lets class types represent objects, while JSON has a limited set of primitive types. Next, we're going to answer the question, what is an AI agent? An artificial intelligence agent is an autonomous AI system that does more than just follow instructions and independently thinks. Additionally, it can access outside data using tools to enhance their responses. They also continue to learn off of data from past interactions to improve their performances, and they are aware of their environment and context through the use of tools. Tools allow AI agents to have a wider access to information and functionalities beyond what they are programmed with at the start. There are various tools that an AI agent can use, such as APIs, databases, web searching, and weather searching. Meanwhile, traditional AI systems are very limited to the tools they have access to, and only look at the relevant information based on the user inputs. In the CodeBasics YouTube video, the example they used to showcase the differences between the two systems involved waiters. Let's say waiter 1 is an AI agent and waiter 2 is a traditional AI system. Waiter 2 may be more intelligent than waiter 1, but when serving customers, waiter number 2 might not make any suggestions or try to look at the environment or context that they're in. On the other hand, waiter 1 may be less intelligent, but it will look at its surroundings and context to make suggestions to the customer. For example, if it is cold outside, waiter number 1 might suggest to the customer to order hot soup to keep them warm. Or, if they recognize that they are a frequent customer, they will go back to old databases and they might remember their past orders and ask if they would like to order again or something similar. Lastly, we're going to go through the steps of how to build a multi-agent AI system. Unfortunately, I'm having some issues with the Python libraries on my laptop and I'm unable to make one at the moment, but we can look at the example provided by the IBM Technology YouTube video. One of the first steps to building a multi-agent AI system is to set up a large language model. In the video, they use Crew AI as a framework because it is specifically designed to build multi-agent systems. Crew AI allows the import of essential classes like crew, task, and agent. The agent class is used to define the individual AI agents within the multi-agent system. They are defined by their own attributes that define its purpose and role. The task class defines the specific task that needs to be accomplished by the agents within the system. And lastly, the crew class is responsible for allowing collaboration between multiple agents and executes each task to achieve the final output. They also allow the integration of important tools such as the SERPer dev tool, which allows the agent to interact with external resources. In order to build and interact with the large language models, the Watson X interface and OS are imported to allow the setup of API keys for the environment. The top left image is a visual to see how the first LLM was set up. It uses the Llama 370B instruct model from MetaLlama and is initialized with the variables model ID, URL, parameters, and project ID. The second LLM is the function calling LLM. In the bottom left image, we can see that it is set up similarly to the first LLM, but under a different model, the IBM Mistral AI Merlinite model. Next, we can now build the actual AI agent itself by using instances of the agent class from the Crew AI framework. In the image on the left, a researcher agent is used as an example. We first have to determine the base LLM that it uses. In this case, the base LLM is the first LLM that was created earlier, and the function calling LLM to handle function calls is our second LLM. Then, the agent's role, goal, and backstory is described along with the tools that the agent can use. For example, a search tool is defined at the top from the SERPer dev tool class. We can also control the use of delegation and verbose of the agent. Delegation allows the agent to communicate with other existing agents within the system, and verbose is the level of the output, meaning how many words the agent uses for its output. We can now create tasks using the task class from the Crew AI and defining the description and expected output. The output file will be the name of the file that the agent will store the output in, and the agent would be the agent that should perform that specific task. Lastly, we can now create our multi-agent system by defining the crew using the crew class from Crew AI. You would have to determine which agents should go in this crew, what tasks they need to accomplish, and set the verbose level for the final output of all the tasks. Thank you for watching.